Okay. All right. We're good. We're good. Go, Felicia.
Welcome, everyone. Welcome and thank you for joining us on Let's Talk Vaccines. I'm Felicia Cito Lau, and I'm one of the co-chairs of the Parent Involvement Advisory Committee at the TDSB. The purpose of
All right.
PIAC is to
We're good.
support
We're good.
the purpose of PIAC is to support, encourage,
Go,
and
Felicia.
enhance parent engagement at the
Welcome,
board level.
everyone. Welcome and thank you for joining us on Let's Talk Vaccines. I'm
In order to improve student achievement and well-being. And that's from Ontario Regulation 330/10, Section 6 of the Education Act. We
we're good.
wanted to let you know that PIAC is made up of
Purpose of PIAC is to support,
volunteers from all
encourage,
22 wards of the City of
engagement.
Toronto.
Welcome.
Please consider checking us out at www.torontopiac.com and look for your ward representative. Or if you don't have a ward representative, consider reaching out to your trustee and joining us as a ward representative. Or if you'd like, please consider joining one of our many working groups that are open to community members. And you can find a list there on our website, as I mentioned, at torontopiac.com. At this time, I'd like to start us off with the land acknowledgement. I'd like to say that we acknowledge we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. I'd like to welcome Michelle Monroe to please share the conversation agreement.
Good afternoon, good evening, everyone. Thank you so much for joining us. My name is Michelle Monroe. I am the Central Coordinator for Parent and Community Engagement with the Toronto District School Board. Thank you for being with us. We've been hosting the conversation series now since we've actually been in the COVID starting about a year ago. The conversation series features conversations that parents or caregivers are asking us to explore or go a little deeper in. We've brought you great speakers over the last year, and we're so pleased that we can bring you this conversation this evening. We have quick guidelines around the conversations that we're having. We just ask that you remain respectful during the conversation. You open to hear information and receive it. That you recognize we all come from varying experiences in our journey, and that we need to value each other in that space. And that if you are going to be communicating us via chat, you keep in mind all others that are there, and you do so in a respectful and open way. Thank you again for joining us, and we look forward to this conversation.
Thank you so much, Michelle. And like I said, I'd like to now introduce our speakers on the panel. We have three speakers tonight. We have Dr. Vanita Dubé, and Dr. Dubé is an associate medical officer for Toronto Public Health, and she's in communicable diseases, which she's been since 2006. Dr. Dubé holds a medical degree from the University of Calgary and a Master of Public Health degree from Harvard School of Public Health. Currently, Dr. Dubé has a few research projects ongoing. These include HPV school-based vaccine implementation, vaccine storage and handling, local vaccination coverage rates, and she also speaks a lot about vaccine hesitancy. Thank you for joining us, Dr. Dubé. We also have this evening joining us is Dr. Upton Allen. Dr. Allen is a professor of pediatrics at the University of Toronto. He's head of the Division of Infectious Diseases at the Hospital for Sick Children. And Dr. Allen is also a senior associate scientist in the Child Health Evaluative Sciences program at Sick Kids Research Institute. His primary appointment is, of course, with the Division of Infectious Diseases in the Department of Pediatrics at Sick Kids. He's also cross-appointed as a professor in the Institute of Health Policy, Management, and Evaluation at the University of Toronto. Of special note, I'd like to mention that in 2018, Dr. Allen was awarded the Order of Ontario, which is the highest honor awarded by the province of Ontario, Canada. And also in 2019, he received the Caribbean Public Agency Award for outstanding contributions to infectious diseases and blood disorder research and capacity building. Thank you for joining us. And last but not least, we have Nicole Welch. Nicole Welch is the director of COVID-19 School Response Team, and she's a Chief Nursing Officer with Toronto Public Health. Nicole holds a Master's of Science degree in Nursing Science and a Bachelor of Science in Biology from McMaster University. Nicole is a doctoral candidate at the University of Toronto in Applied Psychology and Human Development. Thank you to all three of you for joining us this evening. I think we have Dr. Dubé starting us off.
Great, thank you for having us and welcome everyone. Thank you for sharing your time wherever you're at, whether you're watching this live or as a recording. We appreciate your interest. We hope to be able to answer some of your questions about COVID vaccines, especially with the recent news that yesterday children 12 years and older will be, the vaccine Pfizer is licensed to them. So let's get going. So let's start first by talking just very briefly about COVID-19. We've been living with this pandemic for the past year plus. We know that this infection can cause damage to many organs in our body. The one thing that we sometimes forget is that there is something called a COVID long or long haulers, and that's when people who have had COVID, even after they're no longer contagious, can have symptoms that can linger, that can sometimes be debilitating, where they can have what they describe as brain fog, confusion, fatigue, poor exercise tolerance. And when we talk about preventing COVID with vaccines, we can also prevent COVID long. Now, vaccines certainly can help. Vaccines that are used in Canada are safe and they work, and we're going to talk more about them. And the goal of the vaccination program is to protect us from serious illness. So to keep us from getting out of, not going into the hospital and not dying. Now, there's power in numbers. 1.19 billion doses of COVID vaccines have been given worldwide. Over 14 million have been given in Canada alone and 1.2 million in our city alone. And the reason why I tell you these numbers is because with every dose that's given in real life, people are monitored, and if they have side effects, they are reported and kept track of. And this is one of the reasons that we know that the vaccines continue to be safe, because these many doses have been given around the world and can help us to detect whether there are rare side effects that were not detected in the clinical trials. Now, in Canada, we have 4 vaccines that have been licensed: Pfizer, Moderna, AstraZeneca, and Janssen. The Pfizer and Moderna vaccines are what we called messenger RNA technology, and the AstraZeneca and Janssen vaccines are what we call viral vector vaccines. The viral vector vaccines have to be given to adults, older adults, 40 and 30 and above. The Pfizer is now licensed down to age 12, Moderna down to 18. Except for the Janssen or the Johnson & Johnson vaccine, the other vaccines require 2 doses. Now, people often ask, how are the vaccines developed and approved so fast? Did they not cut corners? And I want you to know that no, they did not. The vaccine development process actually began 10 years ago. The messenger RNA technology, the viral vector technology, has been around for a decade or more. Scientists then, once we knew which virus was causing COVID, once that genomic sequencing was set out, scientists then went out to actually use that to develop a vaccine. But they did not cut corners. And so they still did phase 1, phase 2, phase 3 clinical trials. And when the trials were completed, they then submitted their applications to Health Canada. Now, what was different was First of all, the manufacturers had global funding, government funding to be able to do their trials quickly. But they also then, as they completed one trial, submitted their application in an iterative process. And so that's why when the last trial was done, some of the review was already completed. And that's why they were able to then approve the vaccine faster. But they did not cut corners. And even after a vaccine is approved, again, there is that ongoing monitoring. Every time someone gets a vaccine, if they have side effects, physicians and healthcare providers are actually required by law to report those side effects to public health. So people have that question, are the vaccines safe? And the answer is yes. The vaccines have met Health Canada's safety and quality standards. They were tested in large trials before they were approved. We now continue to monitor them when people are getting vaccinated in the millions. And we know that you can get side effects from the vaccine, but most of them are mild and do go away after a few days. And so in particular, these COVID-19 vaccines, they've actually been tested in the elderly, which is great. Usually vaccines are not tested in seniors, but we know actually that it's safe in seniors and it works. It's also been tested in people who have health conditions, heart disease, diabetes, asthma, blood pressure, a weakened immune system, even autoimmune disorders, even in pregnancy. The vaccines are continuing to show that they are safe. Now, how do these vaccines work? These vaccines have what we call an instruction manual. The messenger RNA or the viral vector has coding in it, so when it's injected in your body, it gives your body instructions to make a protein. The protein that you make is called the spike protein. It's the protein that's on the tip of the virus. Once you make that spike protein, your body then recognizes that that protein is not natural to your body, and so then your body makes antibodies against that protein. By making the antibodies, your body gets rid of the protein. The actual messenger RNA or instructions actually don't last in your body for very long. But what you're left with is those antibodies, and those antibodies then are there so that if you are exposed to COVID, your body will be able to fight the infection. So people often wonder, well, what is in the vaccines? Well, the vaccines have this instruction manual. The instruction manual is very delicate. And so to look after the instruction manual, there's lipids, salts, sugars, and buffers. It's also stored for the messenger RNA vaccines in the deep cold. That also helps to preserve it. But look what's not in the vaccines. There's no eggs, there's no gelatin, there are no preservatives, there's no latex, there's no antibiotics. There's also no COVID virus in the vaccine, so you cannot get COVID from the vaccines. Now, what if you have allergies? Actually, most people who have allergies can very safely get this vaccine. A severe nut allergy, environmental allergy, bee stings, antibiotics, the vaccine is safe in all of those allergies. There are 3 ingredients that you have to watch for. And if you have severe allergies to any of these 3 ingredients, then you need to speak to your doctor about it. And the 3 ingredients are polyethylene glycol, tromethamine, and polysorbate 80. Now, if you've never heard of these ingredients, the likelihood is that you do not have an allergy to them. But let me just explain them a bit further. So polyethylene glycol is found in laxatives, a very common laxative given to children, something called Restoralax. The active ingredient there is PEG, that's polyethylene glycol. If you've ever had a liquid gel cap or those red easy tabs, again, that's polyethylene glycol in those products. Tromethamine is found in contrast media for CT scans or MRI scans. And then polysorbate 80 is found in a lot of things, processed foods, in creams, lotions, and over-the-counter medications. Okay, so let's move on. And, you may wonder, well, will I get sick after I get the vaccine? Well, we know you can't get COVID from the vaccine because there's no COVID in the vaccine. You can get side effects, but most of them are mild and will go away after a few days. You can get a severe allergic reaction. It is rare, but it can happen, and it occurs within the first 15 minutes for the most part, and that's why you stay at the clinic for 15 minutes. And so if you get a severe allergic reaction, we will treat you right away. Now, if you have a severe reaction or your reaction lasts for more than 3 days, that's a sign that you should seek medical attention. So what are the commonest side effects? Well, they're really similar to many other vaccines. Pain, redness, or swelling where you got the needle. About 10 to 20% of people can have a headache, feel tired, fever, chills, nausea, for example. The side effects can actually be worse after the second dose for the Pfizer and Moderna vaccine. And for the AstraZeneca vaccine can actually be worse after the first dose. So what is the urgency right now to vaccinate and to really vaccinate as many people as we can right now? It's because of the variants and the third wave that we are in. We know that the variants that we have in our province and in our city spread more easily and can make you more sick. And we also know, though, that the public health measures and vaccines work to fight against variants. And so you can see here on this graph, the orange are the variants, and you can see that we've had a very high number of cases, but by the stay-at-home orders, you can see the cases are starting to drop. And we know also that vaccines work against variants, and that will help us to get out of this third and worst wave that we've been experiencing. So how do we know that vaccines offer protection against variants? Well, we know that the UK variant, the B117, that is the variant that is the predominant variant here in our province. And that's the same variant that's in the UK. It's also in Israel. And those two countries, for example, have been using the Pfizer and AstraZeneca in the UK and the Pfizer only in Israel. And they've done very well at being able to bring their cases down, and they've started reopening their economy as well. So even when viruses change and you get variants, sometimes even if the vaccine doesn't provide perfect protection, it can provide cross protection as well. And down the road, if there's a new variant that's developed where our current vaccines don't provide protection, we could consider a booster dose. Let's talk about pregnancy and breastfeeding. The first thing we need to realize is that with these new variants, the COVID-19 can be very serious in pregnancy. And so at any time during pregnancy, the pregnant person can book an appointment and get vaccinated right away. And the vaccination is actually safe for the person who's pregnant. It's also safe in breastfeeding. The actual vaccine doesn't pass through the placenta. It doesn't pass into the breast milk. But when the pregnant person is vaccinated, they produce antibodies, and those antibodies can pass through to the baby and through breast milk to protect the baby as well. We also know that there are registries like the one in the USA. Over 100,000 pregnant people have registered to follow them along to ensure that during their pregnancy and afterwards, the vaccine continues to be safe. And there certainly have been people who have delivered, who were vaccinated, and there are no safety concerns that have been identified. Okay, so let's move along now and talk about vaccines in children. The Pfizer vaccine was just announced yesterday that it is approved in Canada for 12 years of age and older. This is the same vaccine that's used in adults. They had a clinical trial done in the US through the fall where they studied over 2,000 children. The vaccine is safe in this age group. That's what the study found. It also found that actually there was a 100% efficacy. None of the youth that were vaccinated got COVID compared to the group that were not vaccinated who got COVID. So as of May 6th, as of today, we currently don't have a plan right now for vaccinating children, but you can expect that there will be a plan to be announced, I'm sure in the coming days or weeks ahead. So right now, the best way to protect children is to follow those public health guidelines and for adults to be vaccinated as soon as they can. Now, what if you or your child had COVID? Should you still get the vaccine? The answer is yes. And that's because even if you had COVID, the protection tends not to last. People have had COVID more than once. As well, the COVID that you had might not protect you against a variant strain. And that's why we still recommend getting vaccinated with the 2 doses. So this is the provincial vaccine rollout. The schedule has been accelerated. So actually, as of today, May the 10th, anyone who's 40 and older, anyone who has a health as of today, May the 6th, 50 and older can book, 18 and older who live in a hotspot, certain health conditions, and certain groups of people who are essential workers and cannot work from home. And as of Monday, even more people can book. As of the week of May the 24th, anyone who's 18 and older can book an appointment to get a vaccine. And so right now is the time to start thinking about ensuring that all the adults in the household are prepared to book and to get vaccinated. Now, I want to spend a few more minutes talking about the Pfizer vaccine. And the reason is because in Ontario, in the next coming weeks and probably few months, this is the predominant vaccine that will be available. And so on average, Ontario is getting over 700,000 doses a week in May. It's going to go up again in June. And this vaccine, over 131 million doses have been given in the USA. And the reason why I tell you that is because that's that many millions of people who have gotten a dose. They've ensured that the vaccine has been safe. If there were any side effects, they were reported, and we would know about any rare side effects that would have been developed. This is the vaccine that's also given at our Toronto Public Health mass immunization clinics. Okay, most people wonder, why are we giving our second dose of the vaccine 4 months later? And there's only one reason why we're doing that in Canada and in Ontario, and that's because we have had vaccine shortages. And so we've had to make some tough decisions. By extending that second dose, it allows us to vaccinate more people. We know with that first dose, you do get good protection. The CDC did a study that showed that after 1 dose, you can get 80% protection with the messenger RNA vaccine, and 2 doses give you that 90% protection. And so by vaccinating more people, getting more people that first dose, we can then get that herd immunity effect. And so what is herd immunity? This is a graphic of herd immunity. The dark blue people are to depict vaccinated, and the green people unvaccinated. And so if one of the green people has COVID, they're surrounded by the blue people, which means that the infection will not spread because the vaccinated people are blocking the infection from spreading. And that's the concept of herd immunity. For SARS-CoV-2, we need anywhere between 60 to 90% of people vaccinated in order to get that herd immunity. Right now in Toronto, we're at about 40% of adults. By next week, we could get up to 50%. So we're certainly making good strides. But because we have the variant COVID, we're going to need higher rates to be able to get to that herd immunity. Now, how can you get vaccinated? There are 4 different types of clinics that are giving vaccines. One is the mass immunization clinics. These are, for example, like the Toronto Public Health clinics, for which there are 9 of them available in the city. Then hospitals have clinics as well, too, that often have specific eligibility. Hospitals are also providing a lot of pop-up clinics. The pop-up clinics are geared to hotspot neighborhoods. They are announced for that neighborhood. They are intended for people in those higher COVID rate areas to get vaccinated in an easier way. There are also pharmacies and primary care providers. These have classically been given the AstraZeneca vaccine. There is a pilot now, though, where some pharmacies are piloting the Pfizer vaccine in Toronto. And then finally, there's the mobile teams and other pop-up clinics. These are clinics that are going to homebound seniors, for example, to congregate settings like shelters as well. Now, if Anyone in Ontario is eligible to get vaccinated based on the criteria. You do not need an OHIP card. If someone does not have an OHIP card, they can call the Toronto Public Health Hotline, who can help them to book without an OHIP card. I also want to let you know that if you or someone you know wants to get vaccinated but does not have a ride to get to an appointment, there are many agencies or ways to be able to get assistance to get to a clinic. Now, vaccine is one of our tools to fight the pandemic, but until we get those rates down in our community, our rates are still very, very high in this third wave. We're going to need to continue to wear our mask, keep a distance, stay home as much as possible, and wash our hands. Now, I just want to spend a few seconds on misinformation. There is a lot of misinformation, false information that's online. It can sound extremely convincing, but sometimes there's no substance to it. And so when you hear something about the vaccine that makes you doubt, please consider the source, read beyond the headlines, dig a little bit deeper, and try and verify the information. The best thing that I can say to you is go to a credible website, or even better, have a conversation with your healthcare provider. Have a phone call conversation with your doctor to get your questions answered. COVID has been more than a disease. We've all felt overwhelmed, scared, confused. By getting vaccinated, we will help all of this, to prevent all of this and get us back to where we want to be. Now, it's okay not to feel okay. We've all felt scared, sad, worried through the pandemic. And I just want to take a few moments to say that if you're not in crisis, but you're looking for support, 211 is a free number that you can call to find out what supports are available for you. Now, by getting vaccinated, we can all be part of something greater. Your shot protects you, but it also protects others around you. And when we're all vaccinated, we can be protected together. And before I sign off, I'm just going to leave you with, this is the number for our Toronto Public Health Hotline. It's open 7 days a week, 8:30 a.m. to 8 p.m., 416-338-7600. And then our website, toronto.ca/COVID-19, where we are constantly posting new information, updating information on the vaccine, where to get vaccinated. So I'm just going to leave you with that as well. And with that, I will turn it back to our team.
Thank you so much, Dr. Dubé. That was a very informative and clear presentation. Thank you so much for joining us. We will have Dr. Allen present next. Dr. Allen, do you have any slides?
Yeah, thank you very much. I'll just have a few very few brief slides. Let me know if you can see my screen. Can you see my screen?
We can see your screen.
Okay.
Actually, we see all your slides at this time.
And can you see the first one that says information session?
Yes, we can.
Okay,
Thank you
great.
so much, Dr. Allen.
So Vinita did such an amazing job that I had to delete a bunch of my slides while she was presenting. So she did what a fantastic presentation. But I just wanted, for maybe 5 or 8 minutes, just to share some slides with you, and mainly to give you some idea of the types of information that we've been sharing with members of different communities, including Black and racialized communities. I obviously take note a lot, and so just have a few slides. There are many questions that often get asked, and Vinita has covered beautifully a number of these. How were the vaccines developed so quickly? Who developed the vaccines? Were Black and racialized folks involved? Were Black and racialized folks involved in the studies? What are the ingredients in the vials? As Vinita has mentioned, will the DNA be altered by mRNA? Do the vaccines affect fertility, and so on and so forth? And obviously, I'm not going to go into these, but these are just 8 types of questions that one often sees. This slide is of the 1918-19 pandemic. And I often look at this with sobering thoughts of, well, gee, could we in 2019 or 2020 or 2021 find ourselves in a situation like this? And I know in planning for pandemic over years, we've always wondered about this, but it's mind-boggling that when you look at what's happening in some parts of the world, including India, you realize, that we're pretty more or less there where they were in 1918, 1919. Three great waves at that time. You hear about pandemic waves. I wanted to highlight 1918, 1919, just to bring out one main point. So the first wave in 1918, you can see, and then there was a second wave actually that started roughly around about the same time as wave 2 of COVID. And then settled down after the holidays, followed by a third wave. There are lots of reasons why the second wave might have been bigger than the others. One of the thoughts was that this second wave was occurring at a time when the respiratory viruses were cycling. And so each year we have the respiratory viral season, typically early fall, all the way through, say, October through to March or so. And so it's in the case of COVID, moving forward, it's really important that we bring things under control so that we don't run into September with a lot of the COVID virus, SARS-CoV-2, circulating, so that it doesn't start to create another wave on top of a background level to give you a thicker wave, because there's a tendency for the respiratory viruses to come each year and cycle each year. And we definitely don't want COVID to get a running start into the respiratory virus season. So it's really important that we do everything that Dr. Dubé has indicated for us to prevent COVID from getting a running start for the next respiratory virus season. Now, this is really nicely covered by Vinita. There's just one thing I just want to mention, and that is in 2002, 2004, we had SARS-1. And the research into the coronavirus vaccines started shortly after that. And indeed, as Benita indicated, there's been work done on mRNA vaccines for years prior to that, and overlapping phases, no phases were left out. But what's really key is that we had SARS-1, which provided an opportunity for work to be done on a virus that is a cousin of the COVID virus. And so in a way, we were fortunate that SARS-1 happened, as bad as it was. And so it's important to note that although we talk about vaccines being developed relatively quickly with overlapping phases and so on and so forth, the work really started thanks to SARS-CoV-1 and then also MERS coronavirus, Middle East Respiratory Syndrome coronavirus, that helped to give us a running start as far as vaccine development for the SARS-CoV-2 virus that causes COVID. Now, who are some of the faces behind some of these vaccines? And I thought I would share some of these with you. This is immunologist Kizzmekia Corbett, who co-designed the Moderna vaccine, worked at the NIH. Anthony Fauci credits her with being the brains behind the development of the Moderna vaccine template. We have, Professor Shahin and Dr. Özlem Tureki from Turkey and Germany. The German-Turkish couple who are the brains behind the template for the Pfizer-BioNTech vaccine. Judy Absalon is a very good friend of mine who led the early phase 1/2 trial for Pfizer in the United States and is a major player in the COVID vaccine trials for Pfizer in the United States. A good friend of ours again, Andy Pollard from Oxford University, co-lead for the AstraZeneca vaccine, and another colleague, Shabir Mahdi, who leads the clinical trials of the AstraZeneca in Africa. Just to give you some faces behind the names of the people developing these vaccines, that's not just a company, there's some key people behind, and these are a sample of some of these individuals that many of us know personally and trust a lot. Of course, many distinguished individuals have gotten their vaccines. Queen Elizabeth has gotten her vaccine, Vice President Kamala Harris, the King of Sweden, many Canadians, the two popes, Pope Emeritus and the current Pope. This is a Jamaican, New York reggae singer, Rastafarian Burning Spear, who has received the vaccine. Many individuals from different walks of life have received the vaccine. And people often ask, why are certain groups prioritized? And I think it's captured the essence of it in this slide, where as of mid-January, 50% of Ontario's COVID-19 deaths outside of long-term care facilities and retirement homes were occurring in 4% of the population above 60. Half of the admissions to hospital were concentrated in about 10% of the population above 16. And these highest risk populations could be and can be reliably identified using their age and their neighborhoods of residence that essentially define priority areas for targeted, so that individuals are in hot zones are targeted because they're hot zones of COVID and nothing else. And so it's really important that that message is clear. There's clear evidence that different groups of individuals were involved in these vaccine trials, illustrated here with Pfizer and Moderna, where in the case of the Black population, 12% of the US population being Black and about 10% in the clinical trials. And so the various companies have made an effort to diversify the study population to better represent the population of the United States. And so this has been very helpful in helping to reassure people that various ethnicities were included in the clinical trials. And I made reference to trials being done in Africa, including South Africa, and then of course, trials have been done in Brazil. Not going to go into this, I believe you alluded to this, but the essence of it is that we know exactly the ingredients that are in the vaccine vials. And so we've looked at this very carefully. We know exactly what's in these. It's not too complicated. These are substances that Vinit has alluded to, have been used in other types of products. And so there really isn't anything that's hidden. And I often say when I tell some of my fellows about what's in the vaccines, I say, you know, the mRNA, the lipids, and sugar and salt solution. It's almost like the mRNA covered by a chocolate coating. It's like a raisin covered by a chocolate coating with salt and sugar solutions. Not that complicated. The AstraZeneca, the ingredients again are there, the common ingredients that we see used in other situations. I'm not going to dwell on the immunology of the virus, but I just wanted to leave you with the next two slides, where the common question is, can the mRNA vaccines or other vaccines modify my DNA? And the answer is flatly no. This is why. Let's take the mRNA vaccines. And I often use the example of a peach, where the inner core of the peach is a seed, and in the middle of that, locked away in a vault, is the DNA in the nucleus of the cell. So that's an example of that. The outer part is called a cytoplasm, and that's where the mRNA resides when you get the mRNA vaccines. This is a fleshy part of the peach. The mRNA doesn't get into the nucleus, and furthermore, for it to change DNA, it would have to first be converted from mRNA to DNA, and then DNA incorporated into DNA. Our bodies don't have the complex sets of enzymes to make the conversion from mRNA to DNA. So it just doesn't happen. The other thing to remember is that mRNA stays around for a very short time. I often say, and Nicole has heard me say this before, it's almost like a postman delivering a message to your home and then leaves immediately. And that's essentially what the mRNA does. It's degraded within a day or so. But what about AstraZeneca and Johnson Johnson vector vaccines? These are a bit different because they use a viral vector, harmless viral vector, in this case, adenovirus. It delivers a DNA. It has a key to the nucleus. It does get into where DNA is, but it's a DNA that's not going to be incorporated into our DNA. It makes mRNA that then gets out into the rest of the cell, and essentially from there on, it's the final common pathway is essentially like the mRNA vaccines. Now, these adenoviruses infect us regularly. This the one that is used is one that doesn't infect us, doesn't cause illness at all. And so essentially, these adenoviruses or DNA viruses, other viruses like chickenpox viruses, cold sore virus, the monovirus or DNA viruses, when they infect us, they don't change our DNA. Our bodies don't have the complex sets of machinery that would make that happen. So again, our DNA remains unchanged, and I thought I would just drill down into some detail for you to illustrate that. So thank you so much.
Thank you so much, Dr. Allen. And we're now going to open up the floor for Q&A. I know I have a few, and Felicia and Nicole, you'll facilitate that because there are a number of them. But let me begin, if I may, with the first one, just simply because two things said by Dr. DeBay and also Dr. Allen has piqued my interest. I am a parent. I have two children. And so my question to you is, with the vaccines now becoming available for children, if adults are vaccinated, why would we have to be vaccinating our children if all the adults around them are getting vaccinated? Dr. Allen, Dr. DeBay, either of you can take that.
So the question is, if adults around are being vaccinated, why do we need to vaccinate our children? It's a really great question. Let me frame it a little bit differently. When we do think of vaccines to protect children, some vaccines, we think of a composite strategy, a strategy aimed at offering individual protection to the child. But we also think of protecting the environment around the child. And so, because there are some children who cannot be vaccinated because of or if they get vaccinated, their immune systems aren't able to respond. It's not just children, but other categories of individuals might not, people with weakened immune systems might not be able to respond. So we protect the individual, and we have a thing that we call ring vaccination, or the cocoon effect, that protects the environment around them. And the two work together. You need that combination strategy, recognizing that there are going to be some situations where some children, and in the case of COVID vaccines, won't be vaccinated for a while, like less than age 12. And so they're the ones where the protection is going to come from the community around them. Does that capture your
Yeah, I could just add to that and say, you know, in the US, they've had a lot more vaccine a lot sooner than us, and they have a lot more adults who are vaccinated. And what you're finding is that COVID is still spreading in schools. It's actually spreading through sports and other recreational activities. And so until we vaccinate children as well, while COVID continues to circulate, children will continue to spread it amongst themselves and can also spread it to more vulnerable adults too. So we really need that herd immunity effect. It includes actually the whole population. It's not just going to be 60 to 90% of adults. It's going to be looking at everyone, every living person, and what the percentage are who are vaccinated. So it will help to protect them, and again, to protect those around them.
Thank you so much. Actually, there's one question to segue into herd immunity, actually. So you mentioned that, Dr. Dubé. One of the questions in the Q&A submitted is, how will you know when you have herd immunity? Is there testing for antibodies? Dr. Dubé or Dr. Allen, either?
Sure, I can start. We certainly won't be testing antibodies widely. Like, we won't say, okay, now you're vaccinated, go and get your antibody test a month later. We don't need to do that. One of the ways we're going to tell with herd immunity is we're going to see the rates of infection drop. It's going to be more than just vaccines that we're going to rely on, though. And then we're going to be able to see them not rise again. That's going to be one of our telltale signs to know that we've got good effects from the population level. And if we find, though, that there are new variants and COVID, we're getting what we call breakthrough infections from vaccines, there may be a booster later on down the road as well, too. There will certainly be studies that will be done to look at the antibody response, and those who were vaccinated in the original trials will continue to be followed to make sure that they have that ongoing protection. So that's how that antibody test will be used, but it won't be used in a day-to-day type of way.
Excellent. If I can jump in, and Felicia, if you don't mind, I see a few about booster shots here, and you just mentioned that, Vanita. So for either you or Dr. Allen, one of the questions here is, with different variants entering Ontario, will these vaccines that we currently have protect us, or will we need booster shots in order to deal with the new variants that pop up in our communities?
Yeah, I can start. It's a really great question. Let me say that one of the wonderful things is that the vaccines that came out first came out with these incredibly high efficacy figures. And all the vaccines are really superb at preventing severe disease and mortality. And so when you have such a high level of efficacy to begin with, and if a certain degree of efficacy becomes knocked off and a vaccine drops to 70%, it still is a pretty good vaccine. So I think it's really important to remember that. Will we need boosters? You know, when you talk to different experts, if you ask them in November of last year, people said, well, we're not so sure. By about January, March, April now, people are saying, you know, it's likely, you know, that's happening. One of the colleagues that I showed you on the slide, I was exchanging emails with her and tried to get her to take part in a webinar that we're doing. And she wasn't able to because they're actually busy essentially rejigging the template for the Moderna vaccine. So I think that it's quite likely that we might need some sort of booster, but we don't know for sure.
Excellent. Thank you, Dr. Allen. There are some questions about side effects. And an individual is asking, and thank you for these questions, that they know of people that have had side effects but have not reported them. So how is the system overall tracking side effects and ensuring that we have a good understanding of what the side effects are? Maybe for Vanita?
Yeah, sure. Good question. So, it actually is dependent upon reporting. Now, it's not all side effects that are reported. I mean, we expect that you're going to have a sore arm. I know when I got my vaccine, my first dose, I had a very sore arm for 36 hours. I didn't report that because that's an expected side effect. It's really what we're trying to capture is serious side effects. We actually call them adverse events following immunization. So within a period after when you received your vaccine, and if something happens that can't even be explained or you're not sure if it was caused by the vaccine, the healthcare provider reports that to public health. Public health then does an investigation and reports it to the province, who reports it to Public Health Agency of Canada. And actually, the Public Health Agency of Canada is reporting every week on Friday the side effects that are reported. And so you can see, so that's how the system works. And so if you have a serious side effect that occurs after vaccination, you don't have to prove that it was caused by the vaccination, but it's associated in time. Even individuals can report directly to public health to have that investigation done. It's actually really important because that's how we can detect rare side effects from occurring. But we're trying to, again, not find the run-of-the-mill stuff. It's to find those serious events. That's what we're really trying to keep track of.
Great, thank you. Dr. Allen, there's a question specific for you. The individual is asking, how come there was no vaccine for SARS?
So that's a really great question. The work relating to the coronavirus vaccines really didn't start in any earnest in any major way until after SARS. And the reason for that is that honestly, when SARS-1 came, it kind of took us by surprise because we were all looking for influenza, the great influenza pandemic. It's kind of what we're looking for. That slide that I showed you, that's what we were looking for. I mean, I remember as an infectious disease person writing a proposal to look at a network to evaluate the pandemic virus when it emerged, along with my colleague Scott Halpern and others, prior to when SARS came. So when SARS came, it was kind of a shock that it turned out to be coronavirus, but then at least solidified in our minds the importance of not only focusing on a virus like the influenza virus, but the other viruses that could cause a major illness in a large set of the population, simply because it's been introduced for the first time. It's novel, it's new, we have no immunity to it. So that's essentially the reason for that.
Great, thank you. Felicia, do you have any additional questions?
Actually, I guess this one was an interesting one from the Q&A. There's a question about how, considering you've shown us what is inside each of the vials, and you're saying that there's no live virus and there's no preservatives, where are these side effects coming from? Like, why are people experiencing side effects? Maybe you can, either Dr. Allen or Dr. Dubé can take that on, please.
I can start, and Vinita could add. So there are different categories of side effects. There are side effects that result from your body's immune response, trying to make antibodies and getting T cells revved up because of these spike proteins that are produced, right? So your body responding to that. We often refer to that as reactogenicity, the fevers and the local soreness and aches and pains. That's one. The second category of side effects would be and those are the more common side effects that the sore arm and the fevers. But then there are the side effects that occur once the vaccines are being used in clinical practice that are picked up because of the excellent monitoring mechanism that is in place to pick up rare signals. Okay, and so the monitoring mechanism that has been put in place has developed, has been able to detect the rare signals. And these signals then allow us to see what the side effects are, if they are related to the vaccine, and then try to figure out the mechanisms that are associated with those. And so, for example, the question of the clots that have been associated rarely with two of the vaccines. Researchers are still trying to get a better understanding of what exactly results in the genesis of the clots. We have some idea of what it is, what it's due to, but how did it all start? What was the initial trigger? That's still a subject of some research. So it's not really the virus. You don't need a virus, a live virus, but it's a combination of the way that the body responds, or perhaps in the case of the clots, whether or not in the response to the spike protein, one has other types of responses that might give you a mechanism that leads to clots in a grossly simplified way. Vinita, anything you want to add?
Thank you. Dr. Dubé, would you like to add anything?
Yeah, no, I think that was a great comprehensive answer. So to define it in a nutshell, you can have allergic reactions to ingredients, and in these viruses, there's actually not a lot of ingredients, and then you can have your body's immune response, and that can give you the reactions. Yeah, so I thought Dr. Allen really explained that well.
Thank you. Nicole, do you see anything? Do you have anything ready?
While Nicole looks, I'll come back again to one again. I'm focusing on the children pieces. So just to clarify, the vaccine that's rolling out for kids are for 12 and up, not 12 below. Would you clarify that?
12 years of age and older, and only for the Pfizer vaccine right now. Some of the other vaccines have trials that are ongoing, but right now only Pfizer has been approved for 12 years and older.
Okay, great. One of the other questions I see here is, I heard a person said that you can still get COVID even if you have gotten the vaccine. Is this true?
Yes, it is possible, and let me just frame that a little differently. When you get vaccines, such as COVID vaccines, I would say there are three outcomes that one is trying to prevent. Number one is you don't want to die from COVID, and these vaccines are amazing with that. Number two, you don't want to be admitted to hospital because you have severe COVID, and these vaccines are amazing with that. And number three is any form of COVID, the milder forms included. And it is possible that with vaccination, you might still get COVID, but if you do get it, it's going to be mild. So that's really important. And there still is research to get that is being done to get a better understanding of you know, the transmissibility of virus in that situation where you're being vaccinated and you got mild COVID versus somebody who wasn't vaccinated and had gotten COVID mild or severe. But bottom line is that if you do get COVID in that situation, it would be expected to be very, very mild or in fact asymptomatic.
Yeah, and I can just add that actually yesterday, Public Health Ontario released a report that looked at of the 3.5 million people in Ontario who were vaccinated from December until the middle of April, 0.06%, so way less than 1%, got COVID. And of those who got COVID, the majority, almost 70%, got COVID within the first 2 weeks of their vaccine. And that's the time that we know that the vaccine actually won't protect you. So we know that the vaccines actually are working very well, even in Ontario, where we have the variants and we have very high rates. And as Dr. Allen said, even should you get COVID, very small risk, it's less likely to take you to hospital.
That is such good news and so hopeful. And I think that's just a message I like hearing over and over again. So every time I hear Dr. Allen and Dr. Dubé, because I do a lot of presentations with them, and I hear them say that, I just smile and feel, you know, this too shall pass. Thank you.
I actually have a question. I guess there's been, what is your messaging? Because the National Advisory Council on Immunizations came out with that statement about the preferred mRNA vaccines over the viral vector vaccines. I guess, what is your messaging to anyone who says, you know, I think I want to wait for a preferred vaccine over, you know, one of the preferred vaccines over one of the viral vector vaccines? What is your messaging to those individuals?
You know, I can start with that one to say, first of all, if you got the AstraZeneca vaccine or you know someone that got the AstraZeneca vaccine, do not regret that decision. In March, in April, that was really the predominant vaccine that we had available, and we still were in a public health crisis. That was a very good choice to make. Part of where we're at right now is we've been able to uncover that there is this rare but serious side effect from AstraZeneca. But the reality is right now, in May, most of the vaccine that's coming in Ontario is mRNA. It's actually going to be Pfizer and Moderna. We actually don't have any new AstraZeneca that's planned to come in the next couple of weeks. And so we're at a situation right now where we have a few doses of AstraZeneca left. We know that it can give you that rare but serious blood clots. But we have an abundant supply that's here and expected to come for the Pfizer and Moderna. And so I think really when you're booking an appointment for at a Toronto Public Health Clinic or even through a hospital, that is the vaccine that you are likely to get, is that messenger RNA vaccine. And we know that that vaccine, again, used in the millions, and there's no confirmed safety signal that has been detected yet.
I agree with Dr. Dubé. It's a very important issue, very important question. When we think of using vaccines for any specific scenario, it's always a trade-off between benefits and risks. And that's going to be carefully looked at moving forward. But I think that it's really important that we recognize that in the fight against COVID, we are in this together as a global international community. And when I checked on the Johns Hopkins website earlier on today, more than 60% of the countries in the world at the moment are planning to use the AstraZeneca vaccine. And so it is still a superb vaccine. It's for any environment is a benefit versus risk scenario. And so I don't want us to leave this session today thinking that, wow, we're going to get away because we're going to use the mRNA vaccines because there's the rest of the world. And I can assure you that the AstraZeneca is still a superb vaccine. And when you do a risk-benefit trade-off, if many countries around the world will still be using it in a very beneficial way.
Thank you so much.
So Felicia, I see one last question before we go. We're a couple minutes over time. Doctors, do you mind if we take the last question just before we wrap up? And then we will close. We've kept you long enough because we know you're all very busy. The last question is, if you got AstraZeneca as your first shot, does it have to be your second shot, or can you get Pfizer or Moderna as your second shot?
I can start if you want, Dr. Allen. So right now, the National Advisory Committee on Immunization has a recommendation that whatever you get for your first dose, it's preferable that you get that for your second dose. But if it's either unknown or not available, that the considerations can be made for that second dose. And so we're in a situation now where second doses will be due in June. And if we don't get more AstraZeneca, we actually will have to make that decision based on a supply question. There may also be people who got AstraZeneca at a time when we didn't know about this rare side effect, who may choose for themselves, which is their own choice, whether they do or don't want it for their second dose. And so there will be new recommendations coming out from the National Advisory Committee on Immunization on what to do in these situations. There actually are studies being done. The UK is doing a very large study of mixed vaccines, Pfizer and AstraZeneca together. And some of the preliminary results are showing that it's safe to have those mixed results. How well they work, there will be more study coming out on that as well too. So in time for those second doses, there will be more guidance available to answer that question more succinctly, unless Dr. Allen has a better response right now.
No, I agree 100%. I think that we really do need the data. That said, if you remember that, I think it might have been the second to last slide that I showed you. In the end, whether or not the message to create spike protein is delivered by your postman, or the message, mRNA, or the message is delivered by the FedEx guy in his truck, the message that your immune system gets for either of these vaccines is through a common pathway, and ultimately they're probably not all that different in terms of the way that our immune response sees things. So I think that it's probably going to be okay eventually, but we do need the data.
Thank you so much to both you, Dr. Allen and Dr. Dubé, and thank you so much, Nicole, for helping out with the Q&A. Thank you to Michelle Monroe and Margaret Horvath of the PCEO office. Thank you everyone for joining us this evening. This recording will be on YouTube, so look for it there. And unfortunately, we ran out of time and weren't able to get to all the questions in the chat or in the Q&A. But we want to thank you on behalf of the Parent Involvement Advisory Committee. I want to thank each and every one of you, and obviously the partnership with the PCEO office for bringing this very important topic and bringing the three of you in to help us learn so much more and discuss this very important topic tonight. And good night, everyone. Thank you.
Thank you.
Thank you. Bye-bye.